Hey guys, how y'all doing? In today's lesson, we'll be talking about the domain and range of a quadratic function. If you watch my video on the linear function, most of these definitions you already have, but let's just do a quick review. Quadratic function is a second-degree polynomial function that can be described by f of x equals ax squared plus bx plus c, where a is not equal to 0, and the graph of the function is always parabolic or U-shaped. If you don't know what a quadratic function looks like right now, you'll get a couple examples down below in the problems. A domain are, of course, a set of input values for the independent variable over which the function is defined, aka all the x values. Range is a set of output values for the dependent variable over which the function is defined, aka all the y values. Of course, a continuous function is a function whose values are continuous or unbroken over the specified domain. Once again, you don't have to pick up your pencil. You can just be drawing your graph and never picking up your pencil or your pen. It's unbroken. Discrete function, a function whose values are distinct and separate and not connect. Values are not continuous. Discrete functions are defined by their domain. Okay. Once again, inequality representations. The verbal description, x is all real numbers less than 5. Inequality notation, x is less than 5. And x is an element of the real numbers. X is all real numbers. X is an element of the real numbers. Y is all real numbers greater than -3 and less than or equal to 6. So we have here y is greater than -3 and less than or equal to 6. And y is an element of the real numbers. And y is all integers greater than or equal to 0. Well, this one, inequality notation, y is greater than or equal to 0. And y is an element of the integers. Remember, natural numbers are denoted by the symbol n. Whole numbers are denoted by the symbol w. Integers are denoted by the symbol z. And real numbers are denoted by the symbol r. Alright, let's get right into it. So this is typically what your quadratic functions are going to look like. You have these U shapes going on right here. Bear with me 1 second, guys. Here, like I was saying, they're these U-shaped looking type of guys. We call them parabolas in the mathematical terms. Okay, just like before, when we're trying to find the domain and range of a linear function, to find the domain, we find all the x values, or aka the independent variables. Well, once again, that's from left to right. And then the range, we find aka all the y values up and down. So in this case, the furthest left point that we have, well, let's see here. Let me be able to write on here. Okay. So I'm going to look at this guy right here. So if I'm looking left to right, seems like the furthest left I go is over here. At this point, -6, 8. And the furthest right I go, well, this arrow is indicating that we're going on forever and ever and ever. My thing doesn't like me anymore. Okay. Yeah, it's going on forever and ever and ever. And never stopping. So it's going forever right. So, once again, since this is a continuous function, we don't have any breaks. We just all these numbers from here, from -6 on. We could write this as x is greater than or equal to -6. Once again, we can be -6, indicated by this solid circle here. If they're open, we couldn't be it, but we can. So we are all numbers greater than -6. So we can write it. Well, let's see if I got it. Oh. So we can write it as x is greater than or equal to -6. And of course, x is an element of the real numbers. Once again, the verbal description is all real numbers greater than or equal to -6. Okay. Looking at this other guy over here, I'm just going to talk about it. If we go furthest left, we go right here. Looks like that's -5. And we can be -5. We can be that point right there. And then we go as far left as we can go. And it looks like we go all the way to where x is 9. Once again, that point would be 9, -8. But the furthest right I go is 9. Once again, the furthest left I go is over here to -7. So, I'm sorry, -5. So we between the values -5 all the way to 9. And once again, we're continuous. So we are all the values between -5, including -5, once again, solid circle, all the way to 9, but not including 9 since we have that open circle. So x is greater than or equal to -5, but less than 9. For the range, we're of course looking up and down. And in this case, if you look at a parabola, it's either going to go have a lowest point, like in this case, or in the other guy over here on this side, we have a maximum point. Okay, and that's the highest it'll ever go. Okay, so parabolas can go either way. They're going to do a U shape opening downward or U shape opening upward. In this case over here, we have our lowest point is -6, is indicated right there, and then we go up forever. So to describe that, of course, we say y is always greater than, because we're going out forever, or equal to -6, because we do contain that point -6 right there. Of course, this point would be 0, -6, y value -6, lowest that we go, and we go up forever. So y is greater than or equal to -6. Over on this side, we see that the lowest we go is right here. Yep, can't really write on the screen right now, but lowest we go is right over here at this point, -8, 9. It's the lowest we go. And then the highest that we go, or our maximum y value, would be right here at the top of the arc, or the U shape, where we have 0, 8, so the highest we go is 8. So we are once again between, and we can be all these values between -8 and 8 as our graph is continuous. And you can see following this little parabolic curve, we go up and down from -8 all the way 8, so we are between -8 and 8. So therefore y is all real numbers greater than -8, once again because we can't be -8 indicated by the open circle, but less than or equal to 8. Okay, look at the next guy. Alright, real quick, I'm just going to look at the graph, and we'll talk about the domain and range, and then we'll look at the word problem and talk about the domain and range. Because if we're just talking about the graph, it's given by the function -16x squared plus 5.8. And just talking about the function itself, there is no restriction as far as it being a word problem or this thing restricting us. Like looking at the graph, this thing just makes this parabolic curve, goes left and down forever in both sides, and then right and down forever. So with all quadratic function, if you're just given the function, the domain is going to be the set of all real numbers. Because once again, you're going left and right, and you want to find the furthest left point and the furthest right point. Well, in this case, once again, this guy, if you go to the left, you're looking down, and so it has an arrow going down. Well, this is indicating that we're going down and left forever. We will continuously go down and down and down and go left forever. If you go to the other side, you got another arrow indicating we're going to go down and right forever. Because we're going to go down, but we're going to continually keep going, and we're going right. So, always going left and always going right, we're between negative infinity and infinity, or easiest way to say is we're just all real numbers. As far as the range, just talking about the function once again, we go down forever. Okay, but then our highest point would be around 5.8. Okay, once again, that's kind of given to me in the function right here, 5.8, because if I plugged in a 0 in for the x, I get negative 16 times 0, which is, or 0 squared, which is 0 plus 5.8, so I get 5.8. Once again, but that's the x value where I get my maximum range value, so 5.8. It's also kind of given to me in the word problem, so I kind of knew that then. But 5.8 would be my maximum here. And we'll talk more about how to find your maximum value when we get further along, and then we start talking about like vertexes of quadratic functions and more things about quadratic functions. You can actually find this with your calculator, or or there's some algebraic ways to find your vertex. But for right now, these are pretty much given to us. But once again, the highest point we get is 5.8, and we go down forever. So it looks like we're just less than. We got our highest point is 5.8, so we are always less than 5.8. Once again, continues, we go down forever. So like indicated here, y is less than or equal to 5.8, and y is a real number. Now looking at the word problem. Harold used a motion detector to collect data on the distance a ball was from the ground after being dropped from a height of 5.8 feet as a function of time in seconds. The model function Harold calculated was f of x equals negative 16x squared plus 5.8. Create a graph of the model function. Determine the domain and range of the model function. Determine the domain and range of the problem situation. Explain why the domain and range of the model function and the domain and range of the problem situation are different. Once again, we found the domain and range of the model function just looking at the function and describing the domain and range. Now, if we're talking about the domain and range of the problem situation, well, the domain and range is a little bit different because we are restricted by a word problem. For example, our domain is our time. Okay? And Harold dropped the ball when it was 5.8. Well, if we're just talking about domain for real quick, we're talking about our time. Well, our time would have to start at 0 seconds, the moment right before he dropped the ball. We do not have negative seconds, because when the problem we're just talking about when he dropped the ball, from when he dropped the ball to when it landed. So we are restricted from when he started to when it ended. Well, of course, I'm just looking at time here. He started at 0 seconds and ends at, looks like right here at 0.6 seconds. Okay. So of course our domain, and then once again it's continuous, is between 0 and 0.6. So x is greater than or equal to 0, but less than or equal to 0.6. Once again, the amount of time that it took for the ball to fall. Our range, once again looking up and down, or in this case, our distance from detector. Well, we start at 0, and he drops the ball. I'm sorry, we start at 5.8 because he starts at a speed of 5.8. And, of course, until he gets to the detector at 0. So, up and down. Our lowest point is, of course, 0 when it hits the ground. And, of course, at the starting point when it was 5.8 feet in the air. Or, sorry. Yeah, drop from 5.8. So, we're all values between 5.8 and 0, or greater than or equal to 0, but less than or equal to 5.8, and such that y is a real number. So once again, they are different because in the model function, or just looking at this, we can be negative numbers. And the problem situation, we cannot be negative numbers because negative numbers would indicate negative time, which we do not have. Or it also indicate that we are like below the ground, which we do not do. Okay, let's look at some sample problems here. A function is shown on the graph. What is the domain of the function? Once again, just looking at the domain, we are looking left and right. So, the furthest left that we go is right here. At this point, negative 6 oops, sorry, negative 6, comma, oh, it looks like 9. But once again, we're just looking at the x value, so negative 6. The furthest right that we go is over here, where we have the point 5, comma, oh, I was wrong over here. It's not 8 because it's going up by, it looks like 2, so should be 10 over here. And over here, same thing. Once again, continuous function, so it's unbroken. And looking just at the domain, we go all the way left, negative 6, all the way across to 5. So we are x is greater than, well, we can't be that point indicated by this solid circle, so also equal to negative 6. Let me try that again, guys. Once again, x is greater than or equal to negative 6, indicated by the furthest left that we went, but less than, well, the furthest right that we went is 5. That was the greatest value we could be. So, let's see here what indicates the same thing that we just had. All right, we got some verbal description and the inequality notation. The first one says the domain is all real numbers greater than negative 5 and less than 4. Well, we just found that's not true. We are greater than negative 6. The domain is all real numbers greater than negative 6 and less than or equal to 5. Well, that seems correct, but once again, we could be equal to negative 6, and we were not equal to 5, so that one's gone. Inequality notation, C says x is greater than or equal to negative 6, which was true, but less than 5. So the correct answer would be C. Okay. Next one. A quadratic function is shown in the graph. What are the domain and range of the quadratic function? Okay. Once again, to find the domain, we go as left as we can go, which is right here. And we see the furthest left is at this point 1, comma 5. Once again, just paying attention to the x value. Furthest right that we go, well, this guy is indicating that we're going down, and of course, right forever. So, you know, it'd be something like this. We just continuously go right and down. So it looks like our domain is just x. And we start at 1, but we're going on forever. So greater than, because we continuously go right forever. We're always greater than. And the value 1, but once again, we cannot be 1, indicated by that open circle. So there's our domain. And our range, once again, looking up and down. Well, the highest point that we ever get to is over here where x is 3. Once again, we're just looking at the y values for range. But at this point, 3, comma 9. That's the highest we get to. The lowest we get to, well, we continuously go down forever, so there is no lowest point. So our y looks like it's always less than, because less than our highest point, but we're also equal to it because it is contained on the graph. So less than or equal to 9. Can I say that? Because highest we get to is 9, but we're always lower or less than 9. So let's read our answer choices. Domain, all real numbers less than or equal to 9. Well, that's not what we found. B, all real numbers greater than 1. That is true. And range, all real numbers less than or equal to 9. Same thing we kind of found up here. Domain is all real numbers greater than 1. And range is all real numbers less than or equal to 9. So B is the correct answer choice. Next one. This one asks, which graph represents a function with a domain of all real numbers greater than or equal to negative 7 and less than 2? So we want, once again, we're just looking for the domain, so all the x values, so we're looking left and right. We want to be greater than or equal to negative 7 and less than 2. So between -7 and 2. So if we look at A here, A starts at -2 and then says we're greater than -2. Okay, well that already kills that guy. We kills A because we are at least -7. Because that's the furthest left we need to go. Okay, looking at B, the furthest left that he shows here is -3. Once again, we at least need to get to -7, so B is out. C, same kind of issue here. Furthest left we go is -4. Well, I need to get all the way to -7, so C is out. And D. D does show that we go all the way to -7, the furthest left point. And we can be -7, so we are greater than or equal to -7. So once again, a continuous function, and we go forever, not forever, but we go right all the way up to 2, but not including 2. And then we're less than 2. So D is the correct answer choice. All right, real world situation. The graph below represents the height of a golf ball in feet as a function of the elapsed time since it was hit. The golf ball was in the air for 4 seconds. Kind of what our graph shows, elapsed time. We start at 0 when the ball was hit, and we go all the way to 4 seconds. Height of the ball, well, and our graph indicates here that we go at 0, and then the highest it gets to as it gets hit, it's going. The height gets all the way up to 80 feet at 2 seconds. So what are the domain and range of the function? Let's see. So real quick. Once again, our domain would have to be x is greater than or equal to, well, once again, the lowest we get to is 0, and we can be 0 time, but less than or equal to, looks like our ball stops at 4 seconds. So we're between those numbers. Our range is getting highest and lowest. Well, the lowest is when we were on the ground, so at 0 feet height. But we are less than or equal to, well, the highest it ever got to was right over here at 80 feet. So we're always less than or equal to 80. So our answer choice, it looks just like that. Looks like C, where x, the time is greater than or equal to 0, but less than or equal to 4. And range, the height is greater than or equal to 0, but less than or equal to 80. So C would be our correct answer choice. Alright guys, last one. Hopefully you're starting to catch along on domain and range of a quadratic function. Okay. So what is the domain and range of the following quadratic function? Well, this looks more like a real world, just if we're given the function, they graphed it. So the model function. And they didn't give me what the actual function was, but we can just look at the graph and indicate what the domain and range is. Once again, it looks like we go forever left, as indicated by this arrow. Let me draw it. We will continuously go left and down forever. And if we're following along its parabolic curve, we're always going right. And once again, indicated by this arrow, it's continuously going to go down and right forever. So we're forever going left and forever going right. So we're just all real numbers. Or the domain is all real numbers. Or between -infinity to infinity. So if we're looking at our answer choices, A does not say that, nor does C. But B says that x is greater than -infinity but less than infinity. Or x is, and D, also the same thing. Alright, but what about our range? Range is up and down. Well, we go down forever, but our highest point is right here for our y value. And it looks like we get all the way up to 3. And we can be 3 because it is on the graph. So, B says the range is y is less than or equal to 3, which we're always less than 3, but we are also equal to it. So that looks good. Problem with D is saying that we cannot be 3, so he is wrong. Okay, guys, that is today's lesson. Hope you learned something today. If not, well, please rewatch the video. And also, a good resource on this video would be to look at my video on the linear function of domain and range. Kind of the same basic principle, except in this one we do have a parabolic curve, so you do have a maximum or a minimum range value. Alright guys, see y'all soon.